Yes.
Yes. Okay, so let's welcome Philippa.
Hello, I'm going to talk about verification for WASM SpecTech and for WebAssembly in general. These are some of the guys working on such verification. These are the ones from Imperial. There's Conrad leading in Singapore, Sam in Edinburgh, and Joachim is in Lean FRO. But first I'm just going to go back and do a little bit of history so that one gets what's happening. I always like to have an excuse to put up those guys, Gordon and Robin, who really started us all off in some version of that. So we go from operational semantics, structural operational semantics, definition of standard ML, mature proof systems of various forms, partial mechanized language standards, and then a formal specification of WebAssembly. I did some work on mechanizing JavaScript in the ROC theorem prover, and that's how I got into this world. And I know very much many people in the audience because of the JavaScript work, including Suk Young, who took what we were doing and went kapow to this new place that we gave up between ES5 and ES6 because it doubled in standard. And then Suk Young came on board. So, and bizarrely, we've ended up in this project together, and how on earth did that happen? But it did. So on the formal specification of WebAssembly, and Anders Rosberg is very much the leader of that group. And basically, this is where I come in, starting with work that Conrad Watt did on doing a mechanization in Isabel of the WebAssembly standard before it got into publication. So the publication of the draft happened in 2017, correcting mistakes in the formal specification by Conrad. And we came together because I was in this Rockland, and Conrad knows about the Rockland, but went into Isabel land. And then with my student, Rao, we did some work linking the mechanizations together and moving to the first industry WASM 1.0 standard. We're now at 2.0, very much wanting to keep together with the projects, so waiting for each other, as it were. And we've got type safety, correct module instantiation, correct interpreter for WASM 2.0. It's been done this year by Rao and by Antanas in Conrad's group, and we will publish it at some point in a large paper, but it's basically done. And what I really love is this module instantiation. Here's the standard definition. Here's the theorem. And this goes right back to one of my mentors, Robin Milner's agenda, all the way to correct module instantiation of modules of a design that he created in ML. So I love that story very much. We then built on top of the WASM Cert project many applications. Conrad will talk about what he's done in the ISBER world. We also have the ROC world, where Rao earlier this year at Popple talked about creating an interpreter where the results such as progress and correctness of the interpreter come along with the interpreter definition in such a way that the interpreter can be extracted and is efficient, and the proofs have been done and in tandem at the same time and then get thrown away. For those of you who know Phil Wadler's work on getting interpreter from progress, this is the flip way round. There's work on Surtee Rock, and we have a WASM back end by Mayo is the first author. Bas Pitters and Jean Pichon are also involved. And we've got many program logics now beginning to come from the IRIS work. We were there at the beginning connecting WASM Cert to IRIS, and now the Aarhus guys have taken over, and here's the beginning of that stream that's happening. But that's WASM Cert, and we've moved to WASM SpecTech. And the reason for why is not only is the formal semantics very difficult to do with the bottlenecks of Andreas and Conrad in the standard, or there were others, but they're the main ones having to cope with this formal specification. But also then think about what's happening with the mechanization in an interactive theorem prover. We are keeping on track with it in the sense that WASM 2.0 was published this year, and we've done the mechanizations. So we are just about keeping track, but it's an awful lot of work, and can we do better? So 2 years ago, we had a Dagstuhl where basically a gang of us came together and created SpecTech that you've heard about from Sukyung's talk, and it's now been accepted by the standard. Sukyung had a diagram like that. My diagram's slightly different. Just flip it round and squint a bit, and basically it's the same diagram with a little bit missing. So basically we've got the TSL. From it we get the formal specification, prose and interpreter, and Sukyung's done some recent work on the test generation. And the DSL it has this sort of structure. So for example, if we just think of some value types for numbers up there, either integers or floats, we have the notion of type family, where the integers are clumped together and so are the floats. We have operations that can work on the integers or on the floats. Here's how you do variable store. And we have relations where basically it just looks like this. So for example, the command drop takes a value off the stack and drops it. It has the type given the value of the type of the value on the stack to empty sequence, just meaning you've dropped that value, you're not giving it to anyone. And so this is a reduction relation for the operational semantics. We also have various bits of auxiliary function definitions working over the inductive types for numbers. So I've told you about this, and eventually I'll give you some stuff in here. And the middle, I'm not going to talk very much about, but it's there. And in particular, when we get to here, it's beginning to look a little bit like a normal. It's like a declarative semantics. It's actually not, but it's beginning to. So first I want to describe what we've done in 2 MSc projects, which is go from the internal language down to rock directly. And these guys have done it, one last year and one literally submitted last week and hasn't done his Fiverr yet. And basically what's going on, you've got an automatic translation from here to here of the rock definitions and hand proofs of the results. And we've proved preservation and progress. It's very much on the way. And we found real errors with the DSL because of it, some more fundamental than others. And, we'll keep evolving this and get it all better, basically. And just to show where the work got to, we were not working with dependent types at the intermediate language, and in particular, the translation of the type families, what I've just shown you about putting together the integers and the floats, that we haven't done because we can't go direct to rock. And we have lost information about the premises of user-defined types. And I can show that here. If we have two values, different values, we have a way of transferring from one to the other via something looking at like this. And if these types are different, then this conversion function will go. And if they're not different, then you don't even think about it. And we didn't work with those. But basically, because of these MSc projects, we're now doing this project for real. And Diego's a PhD student. Rao has always been supervising the MSc projects along with Conrad. And we are basically on the way to doing it for real. And this is what we're doing. So we got the internal language. We're going to create this language, the mechanized internal language. There's going to be a step towards lots of interactive theorem provers and their definitions. And so the idea is, this is a cute application. Can we have it as a environment for lots of interactive theorem provers? And the answer is yes, because my gang's doing the rock, Conrad's doing Isabel, Joachim Breitner, who was part of the start of all this SpecTech, went to Lean, thought he wasn't going to be able to play anymore, but it turns out Lean are really, really interested, and so he's absolutely doing it. And not only do we have to deliver to the standard, we also have to deliver to Lean FRO now. So that's, this is getting a lot. And Sam in Edinburgh is doing AGTA. So the point is, we knew from our work from here to here that there was a natural thing here to make things nicer. One notion is you've got functions that are defined this way if the psi condition is this, and it's defined that way otherwise. And instead of that otherwise, you could have the not this. And there was a bit of a fight about this actually, because from here, what does it mean to go to the pros? The otherwise is really nice. But from the point of view of what's going on down here, having a more precise idea of what's going on with the psi conditions is there. So that's just one example, and there's lots of things about here is our real normal. That's the way to think of it. This is almost like normal. And in future, where is this going? I've got there's opinionated Imperial people in my group going, this should be the same thing, and we should have just one thing here, losing information to go to the pros and interpreter later. But so these sort of internal structures, over time, I think they could easily change because actually people are opinionated and have good ideas. But the point is, they have to change a way that's compatible with what's going on and not breaking what's going on. So how do we do that? We've got to understand. I think I've done enough of that. So basically, I thought, so we're here. We've got the type families and dependent types, and the type families in particular are quite difficult. So we were exploring monomorphization. We thought monomorphization was going here. So, for example, you have definitions for each of those integers and floats rather than bundling everything up in one. But instead, we've been exploring this at this place because it's also useful to what's going on up here. And what we're finding is we're not quite sure where to put the monomorphization but it might be better here, it might be better here. So we're exploring all these types of issues of what to put where. And what else to say? How much time do I have? Good, good.
Negative minutes.
I have negative minutes, apparently. So, I'm ignoring that. I was given a little bit of leeway because we're sharing. But what I like about this is that not only are we doing something that we hope is useful for the real world language standard, but also we have a place where there are all these theorem provers on the same problem, and we can start really comparing them. So for example, rock is in this place and this place, because for those of you who know what I'm talking about, this is the extrinsic type world. This is meaning do the Agda thing, which is making everything intrinsic so that you're working with world type terms by itself. So rock and lean can also work in this world. So now, actually, which way is better and what about the choices? We can start exploring. So I'm liking this for this sort of reason. Now shall we move to Conrad? In 2 seconds, okay. Or rather 2 minutes. Okay. Sorry? Oh shit. Sorry. So this is what the DSL looks like. This is a demo that Andreas Rosberg hacked up in Dugstall last week. We have got the new idea, this is why I wanted to do it, new idea of lemmas and theorems in the DSL. It's cute. And here it's done in a template way, with the integers and floats all done once and for all in a template way. Here, those lemmas come in its own bit for the specific integers. And here's the rock stuff, all automatically generated. Thank you and sorry, Conrad.
You can have some coffee break time, so.
I won't be too mean. I prepared 2 versions of this talk. One of them is half the length of the other one, so I'm going to give the half.
Oh, you're so smart. So well prepared. Or you knew Philippa.
What did I know?
Oh,
what
yeah.
could I have possibly anticipated here?
In my defense, Sokyum very kindly said that we could have a little bit of time at the pre-break.
A little unfortunate that my taskbar is still showing up. Is there a way to hide the whole thing? Normally there is, right? Okay, it's actually kind of, it's coming off the bottom a little. Actually, I do have some text where that's relevant. Let me try one thing very quickly. Yeah, I'm going to just restart Chrome because sometimes it forgets to grab the... Okay, moment of truth. You know what, let's just go with it, I think, at this point. Okay, so hello everyone, this is about SpecTech in Singapore. The first thing I'm going to be talking about is the stuff we did in Isabel. This is against the handwritten mechanization of WebAssembly, which we called WASMcert Isabel. There was also WASMcert Coq coming out of Philippa's group. The big thing that I was most excited about with WASMcert Isabel is we use it to verify this efficient interpreter, which is now being used by WASMtime, which is a very widely used industry WebAssembly implementation, which is itself maintained by the Bytecode Alliance, and they're using my interpreter as a fuzzing oracle to check their interpreter is correct. So when I say efficient interpreter, fast enough for a fuzzing oracle, probably not fast enough to replace WASM type. And this was the paper. So obviously, we should bring this thing to SpecTech, not only because we then don't need to worry about maintaining WASM cert Isabelle as it exists today, but as WebAssembly gets more features, we want to kind of inherit them as cheaply as possible and not have to update our model manually and push through all those proofs. So we should put this on top of SpecTech. Philippa's group is helping with this by building this nice intermediate representation that's going to go to lots of different theorem provers. So I say, thank you, Philippa's research group. I will use your thing, and I'll take responsibility for the Isabelle bit. So thank you for that. Okay, second thing my group is doing. Why should we trust SpecTech? Because it's really good and very carefully engineered by Suk-Young's group especially. We should verify the most important parts of it though. And a core part of SpecTech is the animation procedure. This is something that's done in the kind of internals of SpecTech to turn a bunch of inductive semantic definitions we have into executable functions. And this powers in particular the reference meta interpreter and the prose specification backend. So it kind of looks like this. A lot of WebAssembly definitions end up being these big inductive definitions. We want to turn them into executable functions. That's something SpecTech does internally automatically in a lot of cases. But how can you trust this transformation is correct? Well, with the magic of theorem proving, we're going to try and mechanize this and do some reasoning about it. Currently, we're doing some work on prototyping the animation algorithm used by SpecTech in MetaRock, with the idea that you could kind of, at the end of the day, if we get this right, you could take some arbitrary rock inductive, push it through our MetaRock animation, and then get an interpreter at the end that has a proof connecting it. This is something that actually mirrors very closely some work that was already done in Isabelle. The Isabelle community is where the animation terminology comes from, so we're kind of following in their footsteps, but I believe no one has done this for Rock so far. If I'm wrong about that, come and correct me in the break. So, I also thought I'd like to talk briefly, given we're talking about kind of the trustworthiness of SpecTech and the meta-theory of SpecTech, what are the bits of SpecTech I dislike the most from a meta-theoretical perspective? These aren't necessarily things we're going to be able to change, because these are things that are kind of discussed as a group, and you know, I've won some, I've lost some in terms of the design of SpecTech. But this is my time, so I get to complain about certain things. I think SpecTech's concept of index types is too complicated. SpecTech has this concept of type-level arithmetic, which allows it to write pretty complicated constraints. So, for example, we can define what's basically an ADT, but we can parameterize that ADT by in this case, it kind of straddles the line between being a number and a type-level number. You'll see what I mean in a second. And then I can write arbitrary predicates over this number. So, for example, if I wanted to define a type that represents an I32, I could say, well, actually, no, this is even more complicated. This is if I want to define like a family of types indexed by number, and then I have some predicate on the number over here. It gets very, very complicated, and it's actually not used that much in SpecTech, but it's still part of the front end. And then later on, I can define a function which takes not only a number, but also an instance of my type parameterized by the same number. So this is like classic dependent type stuff, right? It's really scary. And the fact that you can write arbitrary predicates over this. The thing is, 99% of the WebAssembly specification, it's my contention, doesn't need this, and the 1% that does need it, I believe we should be writing by hand rather than making SpecTech's type system so complicated. But that's kind of where we are today. Maybe I'll get Andreas to change his mind on this at some point in the future. Second complaint, we don't have a good model for evaluation contexts. The original pen and paper specification had these really sophisticated evaluation contexts. In fact, it gets even more complicated than this, because you have a concept of continuations, which allows you to capture evaluation contexts. But you could write nice reduction rules using the pen and paper meta theory like this. You could just say, here's my big crazy evaluation context with all of the kind of things, and then I can say, oh, the semantics of return inside this big evaluation context is you just jump out of all the evaluation contexts. So that's pretty nice. In SpecTech right now, we have to use this more naive semantics where you bubble out of one layer of the evaluation context at a time. So you end up with all of these different reduction rules for every kind of component of the evaluation context. And that is very regular, and it does work, and it makes the animation process easier because you can kind of see exactly computationally what you're doing at each step. But evaluation contexts are really nice, and it's nicer to read on the page, and also it would help with certain things I want to do with generating efficient interpreters from SpecTech in the future. So my contention is we need a better story for evaluation contexts. Third, we can generate an interpreter for the runtime semantics, but we can't generate a type checker from the type system just now. We do define both the type system and the runtime semantics in SpecTech, but we can only animate one of those things. And you may think, wow, this is unfair. Type systems are really kind of non-computational and it's hard to connect that to an algorithm. For WebAssembly specifically, type checking is a single linear pass, and we very carefully design the type system to ensure that's always true. We insert a bajillion annotations everywhere. Everything is fine. So, given that our type checking algorithm is so simple and our type system is set up from the ground up in order to support the type checking algorithm, everything should work. But it doesn't right now, so we've got to do that in future. Okay, last thing I'm going to talk about as part of my half talk, wearing my other hat. On the industry side, I'm one of the chairs of the WebAssembly standards body. I helped design WebAssembly's relaxed memory model for its concurrency specifications. You can decide for yourself if that's a good thing or not that we have a relaxed memory model. And to kind of double down on my sins, I also lead this proposal called the Shared Everything Threads proposal, which is like the second iteration of more complicated threads within WebAssembly, alongside 2 industry representatives. And currently, SpecTech doesn't support even the first iteration of WebAssembly's concurrency model, so we should do that, essentially. For concurrency 1.0, that's kind of what's deployed in the wild today and the things that people are using. We'll need a way to convincingly specify a relaxed memory model in SpecTech. You know, if I was being really ambitious, I'd say, and we should animate it and get an interpreter and blah, 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 but I just settle for defining it convincingly. Second, we need some kind of extension to the top-level concept of a program state. This is just a very surface-level thing. Your program state used to just have one thread, now it has lots of threads. But this does kind of bubble down through all the middle ends and back ends that make certain assumptions about the shape of a WebAssembly state, especially ones connected to the interpreter. So that's going to take a lot of hacking on SpecTech's internals. This is actually a really good test of our kind of proposition that occasionally you'll need to update SpecTech to handle new features, and that's okay. This is probably the update that is least okay for SpecTech, so if we can pull this off, we can basically do anything. But these are all the things we need to do. One interesting aside is JavaScript's relaxed memory model is very similar to WebAssembly's, but currently we just kind of specify them separately, and we don't really do any work to make them kiss. So we should maybe be thinking about ways at a standards level to do that more nicely. For concurrency 2.0, this is the Shared Everything Threads proposal. We're still in the politics phase of standardization, where all the companies are arguing with each other. The core issue is with Threads 1.0, we can share these raw buffers of bytes. In the JavaScript side, these are called shared array buffers. In the WebAssembly side, they're called shared memories, but not garbage collected objects or functions. And it turns out this is really important if you want to compile a garbage collected language to WebAssembly or some kind of program that does dynamic code loading. Because in WebAssembly, dynamic loaded code becomes this kind of function closure that's garbage collected. It really doesn't play well with this concurrency model. So the solution is specify some kind of new garbage collected allocation that's safe to share across threads. If you're in the web standards world, you're kind of curling up into a pretzel when you see the sentence. It's very scary, a lot of politics to do to make some form of this work. And there's a related proposal called shared structs in JavaScript. So this was my stopping off slide in case I had to stop early. So in summary, we want to shift existing verified artifacts to depend on SpecTech, which will make it easier to track new WASM features. We want to build trust in the behavior of SpecTech itself with kind of meta-level reasoning, potentially change some of the weirder parts of SpecTech's meta-theory, make SpecTech understand how concurrency works, and then make more complicated concurrency extensions that will probably break SpecTech again. So that's kind of where I see myself working with SpecTech and WebAssembly in the future. Thank you for your time.
You're like singing rap. So any question? I think we can have 1 or 2 questions from the audience. Okay then, because it's coffee break, we can use this time as questions to Conrad during the coffee break. And we are going to be back at 3:40, and enjoy the coffee break. Thank you.